Hello, chemistry, and today we're going to be talking about chapter 13, liquids and solids, but today we're going to be talking about 13.1, which is exclusively liquids. Hope you guys had a wonderful spring break. Welcome back. Liquid is the least common state of matter in the universe. This is kind of, you don't think of this, but on Earth, our crust is mostly covered by liquid, but the rest of the Earth and the rest of the planets in the solar system and elsewhere are either solids or gases. Liquid is actually the least common state of matter to be found. Liquids only exist in a narrow range of temperature and pressure. You only get liquid water in between 0 degrees Celsius and 100 degrees Celsius at very set pressures. Kinetic theory description of the liquid state. Liquids have no definite shape. They take the shape of their container. They consist of particles, which can be ions, atoms, or molecules. And what a liquid is made of is not important. It's the arrangement and behavior of those particles. Liquid water behaves a lot like liquid nitrogen, a lot like liquid liquid mercury. Kinetics. Kinetics means motions. So liquid particles, like gas particles, are constantly in motion. Liquid particles are much closer together and they have a lower energy than gaseous particles. The attractive forces between them are much stronger. They're much closer together. The attractive forces we're talking about are your dipole-dipole forces, your London dispersion forces, and your hydrogen bonding. Kinetic energy is high enough that the particles aren't all bound, so they're still fluid, but low enough that they don't become gases. Higher kinetic energy means higher temperature. At a higher temperature, they would become a gas. Properties of liquids and the particle model. Liquid in many ways is the intermediate stage between gas and solids. At normal atmospheric pressure, most solids pass through liquid stage before turning into a gas. And on the reverse, most gases become liquids before they become solids. So gas will condensate down to a liquid and then freeze to a solid. Properties of liquids. There's a lot of these. So number one is definite volume. Unlike gases, you have a set volume of liquid. This volume can change a little bit as your temperature and pressure change. Fluidity. Like gases, liquids can flow. Particles are not bound together in fixed positions, but can move about constantly. Definition of a fluid is a substance that can flow and therefore conform to the outline of its container. With this definition, liquids and gases are both fluids, but unlike gas, which exert pressure on all sides of its container, liquids have one free surface that they do not exert pressure on. In our beaker here, this top where it's open to the air is exerting pressure down on it, but it's not exerting pressure up. More properties. They have a relatively high density. At normal atmospheric pressure, liquids are 1,000 times more dense than their gaseous form. The particles are more closely packed together, and the most substances are less dense in their liquid form. Water is an exception. Solid ice is less dense than water, and that's why ice floats. It's really important for how temperature in big bodies of water is maintained. Relative incompressibility. When liquid water is compressed 1,000 times, its volume only decreases by 4%. In this way, they behave very similar to solids. As you compress them, you don't get more or less space. They're confined to the space they have. Because of this, we use fluids in our brakes because unlike solids, they do have the ability to flow. So when you're not using your brake, it's flowing and putting some pressure. But when you compress it, now you have the same amount of volume pressing against your tire, slowing you down. Dissolving ability. When one substance is added to another, so that after mixing, only one physical state is observed, the substance has been dissolved. So when we're talking about physical state, we're talking about liquid, gas, or a solid. So if you dissolve, some water in some salt inside of some water, it becomes a liquid mixture. It's not solid, salt, and liquid water anymore. It's a liquid salt water. Water is a universal solvent. It dissolves a lot of different substances. Solvent is a substance that something is dissolved in, and solute is the substance that is dissolved. The ability to diffuse. Gases diffuse and mix with other gas particles. We talked about that last chapter. Liquids can also diffuse and mix with other liquid particles. It's much slower in liquids than in gases. And then an increased temperature is an increased rate of diffusion. On the video to the right there, I have 3 different glasses of water, one at normal temperature, one at cold, one at hot, and you can see the rates of diffusion are very different. The normal is a lot slower than the hot, and the cold is even slower than the normal. Even more properties. Surface tension, forces that tends to pull adjacent parts of a liquid surface together. These are the molecules being attracted to each other. Makes the surface less penetrable by solid bodies. This allows things to float on the top of a liquid. This is why water drops form. Water drops have the smallest possible surface area to volume ratio. This graphic on the right here is milk. And you can see at the top there all those little drops that are forming. That's because that decreases their surface area. Liquids have the tendency to solidify. When they're cooled, their particles slow down and attractive forces hold the particles in an orderly arrangement. Changing a liquid to a solid is called freezing. Last properties. They have a tendency to evaporate and to boil. Vaporization is the process by which a liquid or solid changes to a gas. And evaporation, the definition, is a process by which particles escape from the surface of a non-boiling liquid and enter the gaseous state. Now, how do they become a gas if it's non-boiling? Well, like any other mixture, it is random. The liquid particles are randomly moving, some fast and some slow. If a few particles move fast enough, they may become hot enough. Remember that if you're moving fast, you have more kinetic energy, and more kinetic energy means more heat. If you become hot enough, that molecule might evaporate even if the solution is not boiling. And then the boiling point, this is the temperature at which a liquid boils. For water, it's 100 degrees Celsius. 13.1 review, this is on page 376. This is page 1 through 4. Feel free, if you guys want, to put all your reviews on the same page. If you guys have any questions, feel free to email me. Hope you guys are having a wonderful Thursday. And I'll send you a video on solids tomorrow.